Welcome to this video lesson on software testing and acceptance. In this lesson, we will cover various aspects of software testing and acceptance. This includes verification and validation testing, identifying undocumented functionality, analyzing security implications of test results, classifying and tracking security-related errors, and much more. Let's dive in. First, let's talk about verification and validation testing, often referred to as V&V. These processes are essential to ensure software correctness. Verification ensures that the software meets specified requirements, while validation checks if the software fulfills its intended purpose. Simply put, verification asks, are we building the product right? Validation asks, are we building the right product? A well-documented software validation and verification plan, or SVVP, is crucial. This plan includes specifications for information, facilities, and coordination needed for V&V activities. Next, we have Management V&V. This involves examining management plans, schedules, requirements, and methods to assess their suitability for the project. Roles involved in Management V&V include decision makers, review leaders, recorders, management and technical staff, and customer representatives. Key considerations in this process are project objectives, the status of the software product, project management plans, anomalies, and threats, as well as resource allocations. Now, let's move on to Technical V&V. This focuses on evaluating the software product itself, including requirements, design documentation, code, user manuals, and release notes. Roles here include decision makers, review leaders, recorders, technical staff, and customer technical staff. Technical V&V aims to discover and report defects and anomalies in the software. Independent testing, often termed independent verification and validation or IV&V, involves third parties to ensure product integrity. The key requirement here is independence from the product being evaluated. This process includes testing and audits conducted by third parties to ensure maximum trust in the product. Next, let's discuss software qualification testing. This testing determines whether the software meets its acceptance criteria. It involves rigorous testing to ensure the product complies with design, performance, and assurance levels stipulated in the contract. Key activities include software design traceability analysis, software design evaluation, and test plan and design generation. Identifying undocumented functionality is another critical aspect. Software must perform only its intended functions. Identifying and documenting all functionalities is crucial to prevent security issues, as undocumented functionalities may provide entry points for attackers. Analyzing security implications of test results is essential. Bugs are scored based on impact and risk. Critical bugs must be fixed to prevent costly issues later. Bug tracking systems help prioritize and manage these fixes. The primary driver for fixing bugs is their impact on the final outcome, especially those that break build criteria. Classifying and tracking security errors involves categorizing security errors into flaws, bugs, behavioral anomalies, errors, and vulnerabilities. Bug tracking is essential for managing these errors, prioritizing fixes based on impact and risk. Security bugs are scored using the DREAD model, which considers damage, reproducibility, exploitability, affected users, and discoverability. Risk scoring is another important topic. Understanding the potential severity of errors is key to management. The Common Vulnerability Scoring System, or CVSS, is a standard method to assess the risk score of vulnerabilities, considering both static and dynamic factors. Securing test data is crucial. Testing requires realistic and representative data. Secure test data should mimic actual production data while maintaining anonymity. Methods to achieve this include generating test data with referential integrity and anonymizing production data for complex environments. In conclusion, this chapter covered various critical aspects of software testing and acceptance.
From V and AMP, V to risk scoring, each element plays a vital role in ensuring that software is secure, functional, and ready for deployment.
Understanding and implementing these principles is key to successful software development and deployment. Quick tips. Always validate and verify software to ensure it meets requirements. Independent testing provides unbiased assurance of product integrity. Track and prioritize bugs based on impact and risk.
Secure and anonymize test data to ensure realistic testing conditions.
Thank you for joining this lesson on software testing and acceptance. Stay tuned for more insights and detailed explorations of secure software development practices.
Feel free to pause, rewind, and re-watch sections of this video to reinforce your understanding.
Good luck with your studies, and see you in the next lesson.